Today we're going to start exploring exponential functions. We've spent all of first semester in linear functions, which made straight lines. Second semester we'll be investigating two different nonlinear functions. The first one is going to be exponential functions. So the equation form of an exponential function is y equals a times b raised to the power of x. Now, just like with our linear slope-intercept form of y equals mx plus b, our a and our b both mean something in the exponential function. So our a is our initial amount. So that's the amount we start with. Our a is our initial amount, and our b is called our factor. That's what we're multiplying by, or that's what we're increasing by. Okay, so we have our initial amount and we have our factor. And then the other thing that you can always know that you're dealing with an exponential function is if it is raised to the exponent of x. That's always a big indicator of an exponential function. Now, there's a couple of parameters that do have to happen. First thing is we can't have a factor of 1. Our b cannot be a 1 because that's just going to give us a straight line. It does nothing. The second one is our b has to be positive. So it can be a 1/100th or 0.00004, it's still positive, but it cannot be a negative number. And the last thing is our initial value cannot be 0. So if you think about that, if my a was a 0, when I multiplied it, it would make my b 0, it would mess everything up. So those are our rules behind it. Now let's just look at what the difference is between an exponential function and a linear function. So when we look at this linear table, what's happening is every time I'm adding 2. So we've got a constant rate of change of adding 2 every single time. But when I look at my exponential, you could look at the first one and go, hey, well, we added 4, but that's not what we did the second time. So this isn't a linear one because it's not got a constant rate of change, but I am multiplying it times 2. And that's the pattern that this exponential function is taking. So yes, both my examples are by 2. 2 is not the issue. It's the fact that linear, we're adding the same number every time. In exponential, we're multiplying by the same number every time. So now we're going to look at these next 4, 1 through 4, and determine, is it a linear or is it an exponential function? So I want you to evaluate all 4 of them with your video paused. Make sure that you've decided which one they are and how come, and then check back for the explanation. Okay, so just check your answers. They were all pretty straightforward. The only thing you might have had trouble with is on number 1. Some people look at that and they see it as divided by 2, but as we're dealing with always multiplying, you're multiplying by a fraction. So if you ever see a table and you go, hey, that should be divided, think of it as a fraction. So in this case, it was a fraction of divided by 2, so it was 1/2. Okay, so on number 5, 6, and 7, you're looking at the equation to determine if it is an exponential function or not. As you do these 3, I want you to keep in mind what we talked about the parameters of what a and b can and cannot be and what the exponent has to be. So do these 3 on your own, pause your video while you do it, and then check back for the explanation. Okay, there were a couple of tricks thrown in there. On number 5, if you just forgot that you've got an a times a b and just looked at -6, you might have tried to say it was not because the 6 was negative. But if you break that down to -1 being your initial amount and 6 being your factor, then yes, it is an exponential function. Number 6 is a bit of a trick because people see it and go, hey, look, a times b to the x power, forgetting that b cannot equal 1. If you put that in your calculator, it's going to make a straight line. And then number 7, again, people kind of look at that and go, oh, that looks similar, that could be it. But our exponent always has to be the x. Okay, on the last 3 on the first page, we are evaluating the given value of x. So what I want you to do is to evaluate it when they tell you that x equals 5. So you're going to put it into your calculator, 3 raised to the power of 5. So all 3 of these, I want you to evaluate them to get the answer and then check back for the explanation. Okay, and these were all very straightforward as long as you put them correctly into your calculator.